My name is Eric Johnson. I am a Senior Developer Advocate for Serverless at AWS. This video is the third of a series designed to help you build serverless applications using the AWS Serverless Application Model, also known as AWS SAM. This video covers using the SAM build command to prepare artifacts for local testing or deployment. Before I dig into the build command's specifics, it is essential to understand that the build process treats each Lambda function or Lambda layer version as a separate entity and applies the build process to each independently of the others. The result is a collection of unique artifacts that, along with other infrastructures declared in the template, make up an application. Okay, let's dig in. AWS SAM offers two types of builds. The first is the native build process for each of the supported AWS Lambda runtimes included with AWS SAM. The second is a custom build process that uses Makefile to specify the steps in processing the build artifact. To declare the desired build method for serverless function, you set the build method parameter under the resources metadata section. If the build method is omitted, then the native runtime build will be used. In addition to Lambda functions, Lambda layer versions can also be built using native runtime or a custom build process. However, if the build method is omitted in the layer version resource, the layer is skipped during the build process. When AWS SAM uses a native runtime build to process application artifacts, each function or layer is built independently with the following process. Step 1. If applicable, any dependencies are installed. Step 2. If the runtime is a compiled programming language, AWS SAM then utilizes the language-specific compiler to compile the code and its dependencies. Step 3. If the packaging type is set to zip, the artifacts are then copied to the .aws SAM output directory. However, the files are not yet zipped, so they can be used for local testing. If the package type is an image, then, using the Docker file, a new version of the local Docker image is created. Step 4. The template.yaml file is copied to the .aws-sam output directory and is updated with the new locations of the artifacts if necessary. When using a custom build, processing the code and copying the final artifact to the AWS SAM output directory is customizable by using a Makefile. Once the Makefile process is complete, AWS SAM then copies the updated template file to the output directory. Now that you have an understanding of how the build process works, let's walk through some examples to see it in action. In this first example, I have an example of a zip-based Hello World template for Node 14. From the root of the project, I run the SAM build command. When the command is complete, I now have an output directory called .aws-sam. If you do not see the directory, make sure that your development environment shows hidden files. In the build directory is a subdirectory called Hello World function. This directory contains the code and all dependencies required to deploy the Lambda function. The template file has also been copied into the root of the build directory. Opening the template, I can see that the code URI parameter has been updated to point at the Hello World function directory in the build directory. In a second example, I have an AWS SAM template that maintains Lambda layers used by multiple applications. I have an SDK layer that contains the AWS SDK, the Amazon CloudWatch embedded metric client, and the AWS X-Ray SDK. I also have a utility layer that includes several different node utilities that I use often. Under each of the layer source directories, I have a package.json file, the dependency manifest for Node. From the project's root, I run the SAM build command, and a new .aws-sam directory is created. This time, under the build directory, I now have a directory for each layer. Expanding the Node SDK's directory, I can see my package file has been copied over, and all the required dependencies are in the node_modules folder. In the previous examples, I have used zip-based Lambda functions. However, let's take a look at an example where the Lambda functions are packaged as a container image. Once again, I run the SAM build command, and AWS SAM builds the application. However, the only thing I find in the .aws-sam/build directory is the updated template file. Opening the template file, I can now see that the image URI parameter has been added, and it points to the newly created container image in my local Docker repository. This allows me to test the function locally using the SAM local command, which is discussed in the next episode. As previously mentioned, AWS SAM allows you to customize a build process by using the custom build option. In this example, I use a custom build to enable Webpack to bundle and minify application code and dependencies. To enable a custom build, I first set the build method to Makefile, as seen on line 27 of this example. I then create a Makefile in the root of the Lambda function code URI, which in this case is the Hello World directory. In the Makefile, I declare a target for the build process. The target must start with the word build, then a dash, and then the logical name of the resource. In this case, the target is called build-hello world function. When AWS SAM runs the make command, it explicitly calls this target to start with. When the target invokes, then my custom commands are run. First, I install the dependencies. I then run Webpack to bundle the code and dependencies into a single file. That file is then copied from the Webpack output directory to the AWS SAM artifact directory. AWS SAM makes this easy by exposing an environment parameter called artifacts_dir that is available in the Makefile. You may have noticed that all of my examples have been in Node. Let's take a look at one of the other available runtimes in this example. I'm going to use SAM build to build a Java 11 Pareto application using Maven as my dependency manager. I get an error indicating that I do not have Maven executable configured on my machine. At this point, I have two options. I can install Maven and any other Java requirements, or I can let AWS SAM help me here by using the use containers flag. Rerunning the command with this additional flag, AWS SAM changes the process. Instead of depending on my machine to be appropriately configured, AWS SAM downloads the proper Docker image needed to build a Java 11 Pareto Lambda function. The rest of the build process is run inside of that container, with the results being placed in the .aws-sam output folder. The use container flag currently works with Node, Python, Ruby, and Java runtime, while others are being evaluated. So far, I have built simple applications with a single Lambda function or layer version. However, what happens when I need to build an application with multiple resources in it? Let's take a look at another example. Opening the template, I can see that I have 5 Lambda function resources. The first 4 are zipped-based functions, and the 5th one is image-based. All of the functions use the Node 14x runtime. I run the SAM build command, and each of the resources is built independently, one at a time. I run the SAM build command again, and even though I haven't changed anything, AWS SAM builds each resource again, one at a time. The SAM build command has 2 handy flags that make this process more efficient. The first is the parallel flag. This tells AWS SAM to build all the resources at the same time. The second is the cache flag, which tells AWS SAM to only build resources that have changed. I run the SAM build command again with these flags included. And now AWS SAM builds all the resources at the same time and stores a cached version. I run the command a final time, and it ends much quicker than before. This time, AWS SAM checked for changes. Finding none, it used the cache version of all the zip-based Lambda functions. The cache flag does not apply to container image-based Lambda functions because the container image may have changed outside of the AWS SAM project. However, SAM build does utilize Docker's ability to cache images in much the same way. This has been an overview of the AWS SAM CLI SAM build command. In this session, I covered how AWS SAM manages to build artifacts with built-in runtime and custom build options. I covered the difference between packaging zip-based and container image-based Lambda functions. I also demonstrated helpful flags like use containers, cached, and parallel. In the next session of this series, I am covering the AWS SAM local command. I encourage you to watch. For more content like this, visit serverlessland.com. Until then, thank you for watching. Again, my name is Eric Johnson, and you can find me on Twitter at EDJGeek. Have a great day, and remember, serverless for everyone.